Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. Hello everyone, in this video we're going to talk about how we can model circular motion. So let me paint you a picture here. We have two people holding, I guess you call it double dutch, right? Two ropes, we're swinging them around. And at the highest point, the rope is 80 inches above the ground. We see that right here. And at the lowest point, the rope is 2 inches above the ground. And we see over here a little bit of a note that the rope makes 2 revolutions per second. So we want to write a model for the height h in inches of a rope as a function of time t in seconds, given that the rope is at its lowest point when t is equal to 0, okay? So let's start off and let's find k. So for k, we're going to need our maximum and we're going to need our minimum. So we said our maximum is 80 and our minimum is 2. So now for k, we're going to add those together. So 80 plus 2, and we're going to divide that by 2. So now we get 82 over 2, and we're going to get a value of 41. So we know that k is equal to 41. We'll make a note of that, okay? All right, and so now let's think about, do we need this to be a sine or a cosine function? Well, it says that our rope is at its lowest point when time is equal to 0. So that's going to actually be a cosine function, because we think about it, when time is equal to 0, that would be like when x is equal to 0, and we're at our lowest point. So if we think about cosine, right, whenever we have cosine, we start our graph at 0 comma amplitude. So notice, and also for sine, we start at the origin, right? So for sine, when time is 0, then our rope would also be at 0, right? It wouldn't be at its lowest point. So we know it's going to be cosine, so we have y is equal to a cosine of b times x minus h, and then plus k. And we know that k is 41. But also we know that if our cosine function, if our rope is at its lowest point, whenever time is equal to 0, there's actually going to be a reflection involved here. So we have reflection over the x-axis, and there's also going to be no horizontal shift. Okay, so that means h is going to still be equal to 0, but since there's a reflection, a needs to be less than 0. So whenever we find a, we just need to make it opposite, okay? All right, so speaking of finding a, let's go ahead and do that. That would be our amplitude. Okay, so for amplitude, we're going to take our maximum and minimum and actually subtract them and then divide by 2. So here we're going to do 78 divided by 2. And that's going to give me 39. And we said that a needs to be less than 0. So let's say that a is equal to negative 39. Okay? So now we have a, we have h, we have k. All that's left is to find b. So for b, we're going to use our period to find b. So for period, we know that is 2 pi over b. And we think back to our problem, it said that the rope makes 2 revolutions per second. So if we're making 2 revolutions per second, then we would say we're making 1 revolution every 0.5 seconds. So our period in this case would be 0.5. So we take 2 pi over b, and we set it equal to 0.5. So now that's going to give me 0.5b is equal to 2 pi. Divide both sides by 0.5 to figure out what b is. So 2 pi divided by a half would be like 2 pi times 2, and we're going to get 4 pi for b. So now we know, hey, it's cosine, k is 41, h is 0, a is negative 39, and b is 4 pi. We can plug all that information in to write our model. So now we have y is equal to negative 39, cosine of 4 pi, and this would be x, but we're using t for time. And then we have plus, and our k value was 41, okay? So our final function would be y equals negative 39 cosine 4 pi t plus 41, okay? And that is how you can model circular motion.